So we are live now. We can start with the problems. So let me write. Some special problems. On cellular theory. So let us look at some problems. The first problem, like I will write, there is a purpose for that. Like you understand each and everything, because the thing is that in the exam we can get a very twisted problem, and that you have to expect.
Yeah.
So we have a service provider. We have a service provider. So telecom service provider. So a service provider uses cellular theory. All the concepts which we have seen, the concepts of cellular theory. So we have a service provider XYZ. He uses all those concepts of cellular theory to allocate the available frequency range. Allocate the available frequency range. So here the frequency range is given. And frequency range is given to be 850 to 920 megahertz. So this is a very important interpretation we have to make from this statement. So here the frequency range, the band is from 850 to 920, not from 0 to 850. The frequency range, the starting frequency is 850, the highest possible frequency is 920. So this band is given. So this the group of frequencies lying from 850 to 920 is the frequency band which is available to us. This is the total frequency. And the service provider, he makes use of a cluster size. Using a cluster size of n is equal to 7. Now what we have to do, and we have to assume, like some assumptions we have to make, assuming each user needs 8 kilohertz for voice calls. This is the scenario. Now, so this is the scenario given to us, and based on that, we have to find some parameters. So first we have to find the total number of users supported per cell. The total number of users supported per cell. The second very important observation, like the thing they are asking, the total number of users supported per cell if 1200 cell sectoring is used. Oh, sorry, 120-degree cell sectoring. I'm sorry for this. 120-degree. The total number of users supported per cell if 120-degree cell sectoring is used. And the last part. If TDMA eight users is used in each sector of a cell, in every sector of a cell, TDMA, like time, division, multiple access. So 8 users can access a particular frequency channel simultaneously. If it is used, calculate the number of users in a cell. Calculate the number of users in a cell. So this is the complete scenario given to us. Now let us solve this one by one. So first, let us what we can do is whatever is given to us. Let us first identify that.
Okay.
So if I just write given, so can we identify the available frequency range?
Yes.
What it is?
850 to 920 megahertz.
No, so
The average of that.
no, that is what. or let us be smart. Let us not do the given things, because given things so we can see from there itself. We can straight away solve the problem. So first, what we have to do, A part, the total number of users supported per cell. First, let us calculate that. So for that, what we have to do, see, total number of users supported per cell. So first we have to calculate uh, frequencies, range of frequencies available to the cell. So the first step will be to check to get the total bandwidth of the system. So I am writing the solution.
Yeah, sure.
Okay, can you tell me the total bandwidth of the system?
Uh, Total bandwidth 70 megahertz.
Very nice. Total bandwidth available. That's the right answer. It will be equal to 920 megahertz minus 850 megahertz. It will be 70 megahertz. Can we convert it into kilohertz?
70 into uh, 10 power 3. 70,000 kilohertz.
Okay, that is right. That is right. So the total available bandwidth is 70,000 kilohertz. Now tell me one thing. So this is the available bandwidth, and this uh, uh, many frequencies are being shared.
Yes.
Okay. So next is the uh, available bandwidth per cell. Let us calculate. Let me bring it down. Available bandwidth per cell. What it will be?
Available bandwidth per cell.
Yeah.
Uh,
Cluster size is 7.
Cluster size is 7. So there are 7 channels or 7 frequencies available. Uh, so there are 7 cells in a cluster.
Yeah.
So
That. Yeah.
so 70,000 kilohertz by 7.
Very nice. That is right. Available bandwidth per cell will be 70,000 kilohertz by 7. So it will be equal to 10,000 kilohertz. Ten thousand kilohertz. This is very clear. Now, what we have to find total number of users supported per cell, and it is given that each user needs 8 kilohertz. I think that we can calculate. Total number of users supported per cell. And what it will be?
Total number of users supported per cell. So there each cell has a bandwidth of 10,000 kilohertz, and uh, each user needs 8 kilohertz. So the number of users will be 10,000 by 8.
Very good. It will be 1250. So this is the first answer. Answer for the part A.
Okay, sir.
Total number of users supported per cell. Now in the part B, they are asking total number of users supported per cell if 120-degree cell sectoring is used. Now let us discuss this scenario. For 120-degree cell sectoring. See, we know that whenever we do the 120-degree cell sectoring, so every cell will be broken into 3 sectors.
Yes.
So whatever bandwidth is available for the cell, so divided by 3 will be the bandwidth available for the sector.
Yes, sir.
So I can say something like this. Available bandwidth per sector. Available bandwidth per sector. It will be equal to
this 70,000 by 3.
yeah, available bandwidth per cell divided by 3, and available bandwidth per cell we saw it is 10,000 kilohertz. So available bandwidth per sector is available bandwidth per cell, isn't it?
Yeah.
Because whatever bandwidth will be given to cell, that will be divided into 3, no?
Yeah, yeah. Sir.
Yeah.
Sir, so that time we got 15,000. That is wrong.
Yeah, actually, you misinterpreted that it is the total bandwidth available, na? You
Yeah.
took the average of it, but you have to do the difference of it, 70 megahertz.
Oh, okay, okay.
Rest everything was correct.
Okay.
So it is 10,000 by 3. So let me keep it like this, 10,000. Now we can calculate number of users per sector. Number of users
Number of users.
per sector. So whatever is the available bandwidth per sector divided by 8 kilohertz, because every user will be using 8 kilohertz. So whatever is the bandwidth of the sector, we can divide it by the 8 kilohertz.
Number of users. Yeah. Number of users.
It will be 10,000 kilohertz by 3 into 1 by 8 kilohertz.
8. Oh, okay. So 1250 by 3. So
Yeah. Let us keep it like this. 1250 by. So this is the number of users per sector. But
yeah.
if I want to calculate, because in the question they are asking total number of users per cell.
Yeah.
So let us calculate that.
Per cell means into 3, right?
Into 3, yeah.
So 1250 is the answer.
Yeah, same. But we have to show this calculation.
Yeah, step marking.
Yeah. So this is the right way, the way I'm doing. Total
Yes.
number of users supported per cell. One two five zero by 3 into 3. It is 1250 users. So this question is also done. So we completed the A part and B part. Now the C part is if TDMA, like time division multiple access, is 8 users. So very important observation you have to make. Whenever I'm talking about TDMA and 8 users, it means that every frequency channel will be accessed by 8 users simultaneously. And hence, the capacity will become 8 times.
Yeah. So can we do directly 1250 into 8?
So if TDMA 8 users is used in each sector of a cell, calculate the number of users in a cell. Yeah, we can do that. But in order to be more precise and in order to get step marks, let us do it step by step. So first, let us calculate the number of users in a sector and let us multiply by 3. So this is the scenario for TDMA. So first let us mention that. First let us mention the scenario. For TDMA. And it would be good if you mention the full form also.
Time division multiple access.
For TDMA, 8 users. So number of users per sector will become 8 times.
Yeah.
And it will be very good if you can just write a line on this. Like in TDMA, every frequency channel will be used simultaneously by 8 users. And hence the channel capacity or the number of users supported will becomes 8 times. And then you write number of users per sector. It will be 8 times. Isn't it?
Yeah.
Total number of users
Number of users.
supported per cell.
Into 3.
So 1250 into 8. It will be, we can use the calculator. 1250.
10,000.
10,
10,000.
10,000. So this 10,000 will be the answer. This 10,000 users will be the- So this is how it has to be done. This problem. What I will do is now at least in one thing we have the solution. Let it be there. Okay, so this is clear. Okay, now let us move to the next question. Let me quickly write the next question. Because this is a very important discussion here. So consider a FDMA, frequency division multiple access cellular system. So we have a FDMA cellular system. So here we have different frequency channels, and those frequency channels are dynamically allocated and they can be accessed with we have 120 hexagonal cells. So in total, we have 120 cells, and we know that the ideal shape of the cell is hexagonal. So we have 120 hexagonal cells, and these and the total system having the FDMA cellular system, it has 900 overall two-way channels per cluster. And very important point is given. Total system capacity is 900, like channel capacity overall. Two-way channels. And they will be used. They will be used by the clusters. Now see what will happen. And it is also given that one more important observation. If this region has to be grouped into a clusters with cluster size, so I will directly write in the bracket. Let us put here cluster size n. Capital N is equal to 12. So these like this is the information given to us, and based on that we have been asked some questions. Let us look at it, what we have to do. The A part. Co-channel reuse ratio. So we have to calculate co-channel reuse ratio. And what it is D by R. Capital D by capital R. This we have to. In the B part, we have to find the number of channels per cell. Number of channels per cell. Number of channels per cell. The C part, total number of channels
Channels per
available for service provider. In entire region. If capital N is equal to 7. The D part. The signal to interference ratio of the system. The signal to interference ratio of the system. Let us do in dB, in decibels. It's very important because S by I it's a ratio. So by default, it does not have any unit. And we can convert it into decibels using a formula 10 log base 10 S by I that we will discuss. If path loss exponent is 4, if path loss exponent is the small n in the formula.
Yeah.
So can you just give me an idea how you will solve this?
A part D by R is directly formula root 3n, which is
Root
uh,
3n. Yeah,
root
so
36.
yeah, very nice. So capital N we know. So A part to very easily we can do it. Let us do that. So I am not writing ABCD, rather I am writing the concepts.
Right. Fine.
Co-channel reuse ratio. D by R is equal to root 3n. Let me mention that it's the solution. So what is capital N in the question? It is 12.
12.
So let me substitute it. Root 3 into 12. So root 36 will be 6. So the answer for the A part is 6.
Yeah, 6.
Okay. Now what we have to do? The number of channels per cell, the B part, number of channels per cell. Now how you
Yeah.
will calculate that number of channels per cell?
So number of channels per cell. For that, we have to see the cluster size.
Okay.
Here, cluster size is 12. So every cluster will have 900 channels given.
Very nice. That is
And
right.
cluster means combination of cells. So here 12 cells are there. So these 12 cells have different frequencies. And the 12 cells together have overall 900 channels. So per cell we can do 900 by 12.
Very nice. That is the right answer. So number of channels per cell. What it will be? It will be total number of channels in the system
By cluster size.
by capital N, like the cluster size. So total number of channels it is given to be 900. Capital N given to be 12. So 900 by 12. 75
Yeah.
channels per cell. Now, what is the C part?
In the entire region, N is 7.
Total number of channels available for service provider in the entire region if capital N is equal to 7. So see here the idea is this. Here the cluster size we have changed. Now N is equal to the capital N is equal to 7. What it means? It means now the cluster size has become 7. So they are asking that if the cluster size becomes 7, what will be the total number of channels available for the service provider in the entire region? In the entire region means we have to consider the 120 hexagonal cells. Because if 120 hexagonal cell is given, it has to be used somewhere. And whenever we are talking about the entire region, all the cells present has to be taken into consideration. So what we have to do, first we have to calculate the number of channels per cell. That is 900 divided by 7, because now the cluster size is 7. So we will get the number of channels for one cell. And if we multiply by 120, we will get total number of channels for the entire region. Let me do
Oh,
it.
wow. Yes, sir.
Yeah. So this is the idea, no?
Yeah, yeah.
So, yeah. Total number of total number of
Sir, so
channels.
if they give 900, like here they give 900 overall channels. So like if they give overall channels, a number like n overall channels, it by default means that overall channels for one cluster, right?
Yeah, yeah. That is
Okay.
right.
By default, it does not mean for one cell. For it means for one cluster.
Yeah, yeah. But if the frequency reuse factor is 1, means to say that I only have one cell, like A, one
Yeah,
cell.
yeah.
Then that one cell is the cluster itself.
Yeah,
Then we don't call it the cluster also.
yeah, yeah. Yeah, it's not a cluster.
Total number of channels available for the service provided in the entire region. For capital N is equal to 7. So first I will calculate channels per cell. Number of channels per cell. It will be 900 divided by 7. And total number of channels in the entire region. So
900
whatever
by 7 into 120.
into 1. Very nice. Total number of channels. Okay. 900 by 7 into 1. So what it will be?
15,428.57.
And what will be the rounded off answer?
15,429.
So let me write.
Or 15,428. Which one, sir?
Yeah, that's a good discussion. See, the idea is that now the channel whatever
Yeah.
we have used it. Now that 0.43 extra channel we can't get now,
Yeah.
so we can call it 15,014, like approximately.
Okay.
So C part is also completed. Now what we have to do next? The signal to interference ratio of the system in dB if path loss exponent is 4. Let us do this. So next we have to calculate signal to interference ratio, SIR, in dB. That's very important. Signal to interference ratio we have to calculate, and we have to calculate in dB. decibels. So tell me one thing, how you will do this?
There is a formula like signal to interference ratio equals D by R power small n by I naught, where n is the path loss exponent and I naught is the number of like what to say like a cell size. No, like if it's hexagonal, I naught will be 6.
Co-channel, number of co-channels.
Okay, I naught is the number of co-channels. Yeah.
Here, do we need that I
Huh?
naught? In this question, do you need I naught?
Uh, like hexagonal, so I naught we can take 6.
Whole co-channel reuse ratio, D by R. But I naught. Do you want I naught here?
No.
Here we don't need it now.
Yeah, yeah.
Okay, so always remember whenever we are talking about signal to interference ratio, S by I.
Yeah.
Interference when it occurs when cells of similar frequencies, their signals, they interfere, then only interference will take place. Now,
Yeah, yeah.
so whenever I am talking about signal to interference ratio, I have to consider co-channel, regardless it is given in the question or not. And you are absolutely right that here we have already calculated co-channel use ratio 6. It means that after, like every 6 co-channels, every base station has 6 co-channels. Co-channels means the cell with the same frequencies,
Yeah.
cells with the same frequency group,
Yeah.
isn't it?
Yeah. So,
So yeah, tell.
so I naught will be the same as D by R every time.
No, it depends. We will look in one of the question that if we do 120-degree sectoring,
Uh,
then this I naught will change. Because we have seen now, when we do the sectoring, when we do the cell sectoring, the S by R improves. If S by R improves, then the number of co-channel has to reduce. Because if the number of co-channels will reduce, then interference will reduce.
yeah. So in that case, cell checkering, how to find I naught?
That we will do. That we have to do, we will do it.
Okay.
Okay. Yeah. In this session itself, we will do in one of the
Okay.
problem. Yeah. So path loss exponent is 4. So now to straight away we can substitute the values, I guess. So D by R is 6
Yeah.
to the power of 4 by 6. 6 to the power of 3. And what is 6 to the power of 3?
216.
Now see, this 216, it is not the final answer. Always remember, in this formula, whatever value you calculate now, it is not in dB. It is not
Yeah.
in decibel. It is a pure ratio. This 216 is just a number without any unit. Now we have to convert this pure S by I into dB. So
Yeah.
there is a formula for that, and please become aware of this formula. Very important formula I am sharing with you. S by I in dB is equal to 10 log base 10 normal S by. That's it. It means that it will become 10 log base 10 normal S by I. What it is? 260. Can you solve this?
Yeah, I can solve it.
So tell me.
23.34.
Yeah, that is right. 23.34 dB. Decibel. So this is the answer. So this is done. So now we completed this question. Now we can move to the next question.
Yes, sir.
Now this is a very important question, wherein some more concepts will be clear. A cellular service provider decides to use GSM with TDMA. Which can tolerate the signal to interference ratio of signal to interference ratio. Well, dB. In worst case, find optimal value of n. Assuming small n is equal to 4. For A part, omnidirectional antenna, B part, 120-degree sectoring, and C part, 60-degree sectoring. So the idea is that we have a cellular service provider who decides to use GSM with TDMA, which can tolerate the signal to interference ratio of 12 dB in worst case. So we know that we always want high signal to interference ratio, because if we have a high signal to interference ratio, it means that the power of the signal will be high and interference will be low. That is what we want. And there is always a minima. There is always a minima of signal to interference ratio which we can tolerate. And in this particular scenario, that minima is 12 dB. So anyhow, S by I has to be greater than 12 dB. Anyhow, S by I has to be greater than 12 dB. We have to find the capital N, that is the cluster size, optimal value of capital N. Optimal value of cluster size we have to find, assuming the exponent small n is equal to 4. The path loss exponent, it is 4. And it is in the first scenario, we are assuming that we are using an omnidirectional antenna. In the second scenario, we are using a 120-degree sectoring. And the third scenario, we are using 60-degree sectoring. So let us look at one by one. So solution. So can you tell how to do this?
No, this time a bit clueless.
Okay. For only directional antenna. Okay, do you know any relationship between S by I and S by I and capital N? Signal to interference ratio and the capital N, that is the cluster size. Are you
S
aware
by
of? Yeah, please.
S by I
Mhm.
and capital N.
Mhm.
Uh, S by I equals at S, okay. S by I equals root 3 n power n by I naught.
Very nice, very good. So we have already seen S by I is equal to D by R to the power of N into 1 by I. Or let us call 1 by I. It's fine. Now, here you are already aware that in this question, nothing is given about D and R. So, but we know that D by R is root 3n.
Yeah,
So,
yeah.
let us take it one step forward. Let us take it one step forward. And let us have something like this. S by I is equal to root 3n to the power of n into 1 by 5. Now for omnidirectional antenna will be used in that scenario when there is no cell sectoring. Every cell will be having only one base station, a very powerful, high transmitting base station will be there, omnidirectional antenna will be there. And for that, the co-channel, number of co-channel will be 6. So I naught will be 6.
Sorry, can you repeat?
So for a cell with the omnidirectional antenna, there will be 6 co-channels.
Okay.
So I naught will be 6.
How is it 6 co-channels?
Oh, so you forgot the meaning of. So what is the meaning of co-channel? What is the meaning of? Yeah.
Meaning of co-channel.
Yeah.
Oh yeah, I am from that class. I am co-channels. I am finding a bit difficult concept.
Co-channels are the channels with the same frequency group.
I will note it down.
Yeah, please.
Means I know the formulas and all, but the exact meaning I didn't.
Without meaning, so it's useless, no?
Yeah.
Because without meaning, so how you will interpret the question?
Yeah.
Co-channels
are channels with same frequency group, right?
Yeah.
Cells or channels with same frequency?
Cells with same group. Now let us suppose the center one.
Base station.
Let me put the type. Right, like let it be the base station, like the main base station we are focusing on, and let these be the other base stations. Like this green, so these are the cells, and we call them the co-channel. Why we call them the co-channel? Because whatever the frequency groups or the bandwidth allotted to our main base station, the same bandwidth is allotted. Like not just the bandwidth, but the like same frequency group. Or we can say the same channels, same frequency channels are allotted. And hence they are prone to interference because all of them, they are close also. So their signals contain same frequencies and they are prone to interference.
Yeah. So why are they placed so close?
No, actually I have placed them, but in between there will be some other cells also. Like in between there will be cells. And these cells will be of different frequencies, like frequency groups. So the idea is that now, like every base station, total 6 co-channels are possible. Like in one of the arrangement, like this arrangement. So I naught is 6.
But when we do the
sectoring,
then it might change.
So why the number of co-channel will decrease? Because of the sectoring, every cell will be sectored,
Yeah.
and hence the cluster size will decrease. And when the cluster size will decrease.
Yeah, cluster size will decrease.
Cluster size will decrease, and if the cluster size will decrease, number of co-channel has to decrease. Like the cells sharing the same frequency group, it will decrease, and hence S by I will increase significantly. For 120-degree sectoring and for 60-degree sectoring, S by I will increase significantly.
Okay.
Because we have already seen it. This scenario we have already seen in one of the theory class. We have already seen that we will discuss very soon. But let us first focus on the omnidirectional and let us solve it. Let us first focus on the now what is given in the question is simple, that the minimum S by I is given. Like S by I should have at least 12 dB.
Sir,
Sorry. If you want to discuss anything, WhatsApp me.
what's that?
Other than this, other than any
No,
doubt.
this only.
Yeah, please.
So apart from sectoring, any case, I naught will always be 6, right?
Yeah.
No.
That is. So okay, so it is given in the question that the worst S by I we can have is 12 dB. So S by I cannot go below 12 dB. So S by I has to be at least 12 dB. Decibel. Now we know that this the formula whatever we are getting, it's a pure ratio. So we have to get rid of this dB. We have to get rid of this unit. And how we can get rid of this unit is we make it by using a technique we have already seen. S by I. Like let me do it somewhere else. Let me do it somewhere else. Like side. It is a rough calculation I'm doing. S by I in dB.
dB equals 10 log 10 S by I.
Very nice. That is the pure S by I. And this pure S by I is what we have to calculate. Because S by I in dB, we know it is 12 dB. So this 12 dB, I have to convert it into pure S by I. So what I can do, so this S by I in dB is 12 dBi. So 12 dB, I'm writing the unit so that we don't get confused, by 10. This 10, I'm bringing it to the denominator. It will be log base 10 S by I. Now tell me one thing.
Yeah.
S by I, what it will become? It will become 10 to the power of 1.2.
Yeah.
Because 12 by 10 will be 1.2. And can you calculate its value?
Yeah. 15.84.
15.8. That's the right answer. Like the right value you got. 15.8. So the idea is that now I can write. Now I got rid of this dp. So I can say that S by I has to be greater than or equal to 15.8. Is it clear? Until now,
Yes.
until here, whatever. Okay, very nice. Now we have already we have the formula for S by I. and I not just I have to make it 6, and the small n is given to be 4. So let me substitute it, and when I do the substitution, I will get root 3n to the power of 4 by 6 is greater than or equal to 15.84. And after rounding off, because rounding off is very important. Now, after rounding off, we will get 15.85. Let us be very precise. Always don't forget to round off. Always round off.
15.85.
After rounding off.
Oh. So two decimal digits is enough.
2 decimal digits is enough. So what I can do, I can bring 6 here, and this will become root and 2 will cancel. So 3n square. 3n square should be greater than or equal to 15.85 into 6. N should be greater than or equal to under root of 15.85 into 6 divided by n. What you will get? Please solve and tell me n.
3.25.
3.25. Very nice. That's the right,
Calculate.
yeah, right calculation. 3.2. Now n is a integer, and n should be greater than 3.25. So n cannot be 3 because it has to be greater than 3.25. So n has to be 4. So the answer is 4.
I think we have to refer that possible cluster sizes like 1, 3, 4. I think
No,
like
no, no,
that.
no, 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 not like that. Here, see, n has to be greater than 3.25. No, this according to this.
Yeah.
So n cannot be 3 because it has to be greater than 3.25.
Yeah,
Now,
but I'm telling about 3.25, greater
now,
than 3.25, whichever possible are there,
yeah,
we have
yeah,
to
yeah,
compare. So
yeah,
4 is
that,
possible. So 4
yeah,
we are.
very, very nice, very nice. Yeah, that I agree. That I agree. So n will be the 4. The optimal value for n will be 4. So this is the answer for the A part. Now for the same question, we have to do 120-degree sectoring. Like everything is same, just 120-degree sectoring. Now for 120-degree sectoring, this I naught, this result you can remember, like very important result I'm discussing with you. for 120-degree sectoring, the co-channel cells uh, is 2. So whatever I naught we have, that is the number of co-channel cells, it will become 2. For omnidirectional, it is 6. For 120-degree sectoring, it is 2. And for 60-degree sectoring, it is 1. It's so interesting that when we do the 60-degree sectoring, no co-channel will exist. No co-channel will exist. And everything will be same. In the formula, just I naught we have to change.
Can you repeat once?
I naught I have to change that. Let me copy this formula. So what I am telling is that for 120-degree sectoring, I naught, it will become 2. Please remember that.
120-degree I naught will become, oh, from 6 it will become 2. How, sir?
Yeah. So the derivation of that we will do some other day.
Okay.
But now please remember this. There is a reason for that we will do. But now you remember it like a result.
Okay.
See this S by I greater than 15.85, it has to be same. Nothing will change. Now only the thing that will change is the value. So what I will do, S by I root 3n to the power of 4 by 2. It has to be greater than or equal to 15.85. 2 I can take that side. 3n square has to be greater than or equal to 15.85 into 2, and has to be greater than or equal to 15.85 into 2 by 9 under root. And please calculate and let me know the answer.
One second, sir. I'll copy.
It will be 1.88 and should be greater than or equal to 1.8. N has to be 2. So the answer will be N. N is equal to 2. And see, we prove that when we do the sectoring, the cluster size decreases. The cluster size from 4, it went to 2
Yeah.
in 120-degree sectoring. And
Okay.
now we will do the
60.
60 degrees. Now you have to remember that for 60-degree sectoring, I naught will be 1.
Okay.
That's it. Now to same, everything is same, just the values we will be putting, that will change. Let us quickly do this. Now see, it will become root 3n by 4 should be greater than or equal to 15.85. It implies that n should be greater than or equal to root 15.85 by 9. One point three three. So here also it will be 2. Here also it will be 2. So we solved this problem. Okay. This problem is solved. Now let us look at the next problem. Now whatever problem we will be discussing, it will be of a different concept but very important. It will be related to handoffs. And they are like very important problems. I have a mobile user. A mobile user is moving a mobile user is moving from cell site A. A mobile user is moving from cell site capital A to cell site capital B. at the speed of 30 kilometer per hour. Let me highlight it. The radius of the cell site is the radius of the cell site is 600 meter. Assuming handoff occurs assuming handoff occurs over a duration of 5 seconds and at a path loss of 4, calculate minimum required margin of handoff. This we have to calculate. And comment on the effect of margin on the performance of cellular system. Assume D naught is equal to 1 P naught. So D naught is the reference distance from the reference point, and P naught is the power received at that reference point. It is 0 dB. Now see in this question, like it's a very important question. Here we have a mobile user and he is moving from cell site A to cell site B. So he is switching from one cell to another cell. The speed is 30 kilometer per hour. The radius of the cell site is given. So every cell, the radius, that is a capital R, it is 600 meter. And the handoff duration is given. So in order to undergo the handoff, 5 seconds are involved. And path loss 4. So small n is the path loss. That is a 4. Calculate the minimum required margin of handoff. So we have to calculate the minimum required margin of handoff and comment on the effect of this margin on the performance of cellular systems. Now let us see how to do this. So in order to solve such problems, we have to make use of one formula, very important formula. That is something like this. PD is equal to P naught minus 10N log base 10 d by. Now here P naught is given, D naught is given.
0.
Yeah, P naught is 0, D naught is 1. And what else is given? Small d. Small d is the distance from the base station at which we are receiving the power. I will write all this very fast, like very important mention I will be making. See what is PD? PD is the received power at distance d. Received power at distance d. P naught is the received power at reference distance d naught. D is the actual distance, and we take a reference distance which is very close to the base station, the antenna, the tower. So P naught is the received power at the reference distance D naught, and N is the path loss exponent. isn't it?
Yeah.
Now, from the speed which is given and the handoff duration it is given, can we calculate the distance traveled during the handoff? Because
Yeah.
for handoff, it took 5 seconds. So distance traveled during those 5 seconds we can calculate.
Hmm. Hmm. Hmm.
So let us do that. Distance traveled during handoff. What is distance? Speed
Speed
into
into
time.
time.
And speed is 30 kilometers per hour. Can we convert it into meter per second?
Yeah.
So what is speed? So it will become 8.33 when we convert it into meter per second. 8.33 meter per
100
second
by 12. 100 into 5. 500 by 12.
into 5 seconds. So it will be 41.67 meters.
41.67. Yeah.
This is the distance traveled during the handoff. So during the handoff, this much distance will be traveled. Now let us calculate the handoff minimum required handoff margin. What it means, first try to understand. What is this handoff margin? So what is this handoff margin? Let me write it. So handoff margin is the difference between the signal strength of the serving cell, that is the cell A, and the threshold at which the handoff to the next cell B is initiated. So this handoff margin is the difference between the signal strength at that point. The idea is that let me help you in understanding this. We have two cells. Cell A and cell B. Let us suppose. Let us suppose we are moving from cell A to B. And we have different cells. This is cell A. Let us suppose I have cell B. Now the idea is that I have a mobile station which is moving from A to B, and this A and B, they have to be close to each other. They are like adjacent to each other, for example. Now, if a mobile station moves from A to B, let us suppose it is somewhere here. Now, at this point, what is the power received? Like the signals of A, which the mobile station is receiving the power of those signals, that minus the threshold. Threshold means minimum power required by the tower B to initiate the handoff. Because yeah, the idea is that when I am moving from cell A to cell B, instantly I will not do the handoff. Once I start receiving the signals of B, then only I will initiate the process of handoff. So once I am moving from A to B, there is a threshold. Threshold means minimum signal power of station B. Once I receive that threshold power, then I will do the switching. Then switching will take place. Then I will start receiving, like I will switch from A to B. So the concept of margin is clear. So what is the concept of handoff margin? Difference of the strength of the signals of tower A minus threshold power signals of tower B. In easy words, I am explaining this. So we have to calculate the difference in the signal strength.
Sir, 1 second, I will note it down.
Yeah. Now the idea is very clear. From here to here, the distance is 600 meter. It's given.
Sir, so handoff margin is the difference between the power of the signal of A.
Yeah. At that
And
point. Yeah.
difference between the power of signal from A
Oh,
at
okay.
that.
Yeah. No, you will get a clarity. Now, when we will solve this, you will get a complete clarity what we are doing. So see, just understand this point. From center to the edge, the distance is 600 meter, and from edge to the point where the to which the mobile station moved in 5 seconds, that is 41.67 meter. Are you convinced with this?
Yes.
Because 600 by I am taking, because in the question it is given the radius of the cell is 600. Somewhere it was written. Yeah, the radius of the cell site is 600 meter. It's given in the question itself. Can you see this?
Yeah.
So now this is very clear to us that because for handoff now from the edge, once the mobile station start entering the B, so once it travel 41.67 meter inside B, then handoff will be initiated. So these two scenarios are clear. Now, according to these scenarios, we will make some observations. Now, tell me one thing. At the edge of the cell, at the edge of the cell, what will be D? D will be 600 meter. Because when I will reach the edge of the cell, what will be the distance? What is small d? Small d is distance from the base station. So when I will reach the edge of the cell A, the distance from the base station will be 600 meter. So power received, I can calculate the PD. What is PD? PD is the received power at distance t. So received power at the edge, it will be according to the formula P naught minus 10 n log base 10 d by d naught. Now I with appropriate substitutions, what I will get? What is P naught? P naught is given
0.
0. What is n?
4.
Log base 10. D is 600. And what is D naught? 1. It's given. And when I will solve it, I will get minus 80 dBm. Is it clear? So
Yes.
This is the strength of the signal, power of the signal from the tower A or from the base station A.
Bigger picture.
After the user
This is a signal from power A at that point.
moves, after the user moves, (41.67 meter) closer. So at this point, what will be the distance of the user from the tower B?
641.6.
No.
From the
B.
From the B.
600 minus.
600 minus 5.
Because for the margin, signal power A minus signal power B we have to do. So A we have calculated, for B we will calculate. When the that handoff initiated, at that point, what was the signal power from the tower B, which is being received by the mobile station? So this distance is 558.33.
Yeah.
Isn't it? Now straight away we can calculate P 558.33. What it will be. So P naught is 0 minus 10 into 4 log base 10. D is 558.3 on 1. When you will solve this, you will get minus 79.47 dBm. So now very clear, whenever you have to calculate the handoff margin, first you calculate the power, signal power from the tower A at the edge. Then once the handoff initiated, at that point, the signal power from the tower B, just take the difference of that. you will get the handoff margin. Now we will do the handoff margin. What will be the handoff margin? It will be, and this very important, it is P 558.33. Like when we take the difference, we have to take it from B to A. Like power received from the tower B minus power received from the tower A. And what is power received? Power received means the signals which we are receiving from the cell B, base station B, its power. It is minus 79.47 minus 18. And what you will get? 0.53 dB. And this is the answer. Handoff margin is this.
Sir,
Yes, please.
sir, so minus 80 is the signal power, power of the signal from A at that point, right?
Yeah, yeah.
Okay.
Yeah, that is right. Yeah.
Power of signal from A at P. And minus 79.47 is the power at that point from B.
Yeah, that is right.
Okay, so power, signal power at B from from the base station of B,
Yeah,
B tower. Uh, okay, and handoff margin will be the difference.
yeah.
Okay, and sir, that time you
Yes.
are telling
Okay.
handoff margin is the difference between the power of signal from A at that point and the threshold something. Can you repeat that?
Yeah, yeah. So now we take this only. The threshold which I was telling was the B. So now you just assume like after all this analysis, the conclusion is that if you have to calculate the handoff margin, if I am going from A to B, then the power received, the power of the signals received from the tower B, from the cell B minus cell A, wherein for cell A, I have to take the distance as the edge, and whatever extra distance, whatever distance I penetrate inside B, that will be what it will be. It will be the at that
Radius,
point
radius
at that
minus.
point I will be calculating the power received by the base station B.
So at that point, handoff margin basically is at that point the power received from the base station of the entering cell minus power is received from the base station of the exiting cell.
Yeah, you can say that. And when exiting cell power you are calculating, you have to calculate the edge of the cell. And entering cell, when you are calculating the power, whatever distance you have entered, that you have to subtract from the radius,
Okay.
isn't it?
Yeah, yeah.
Now let us analyze the handoff margin, the importance of it. Now see, we can have a large handoff margin and we can have a small handoff margin. What will happen if we have a large handoff margin, and what will happen if we have a small handoff margin? What will happen if we have a small margin, and what will happen if we have a large margin? So see, if we have large margin, it is favorable. Large margin is favorable for a handoff. The large margin is favorable. Larger the margin, more easily or more efficiently the handoff will be taking place. So favorable for handoff. But on the other hand, since it's so favorable, we might have early handoffs. And early handoffs means ping pong handoffs. And what is this ping pong handoff? Ping pong handoff means for some time the control is given to B, then once again it is given to A. Ping pong.
Ping pong, table tennis.
Yeah. Here, how the table tennis is done is that if this margin is very high, handoff margin, then very easily handoff will be initiated. There is a reason for that, because see, the idea is that handoff margin is high, it will stop receiving. Because see, what is handoff margin? Handoff margin is difference between the power received by B and A. And if that difference will increase, it means that it is receiving more powerful signals from B as compared to A. Do you agree with this statement? If I increase the handoff margin, what I am doing is that the mobile station is receiving more powerful signals from station B as compared to station A.
Yeah.
Then it has to go for, because it is attracted to a high power. So
Yeah.
it will get attracted towards B. It will do the handoff will be initiated.
Yeah. Sir,
Yeah.
so
Yeah.
ping pong handoff should be for small margin, right?
No.
Because in small margin there is less difference. So in the distance.
No. Why ping pong is that is there? Because when in the boundary region, let us suppose I cross a certain distance, then I will get B. But once again, within B, if I get closer towards A, I will start receiving the A. Why it is happening? Because see, if the difference is large now, handoff will be taking place. The threshold is crossed. But if the margin is small, I will think 10 times before initiating the handoff.
Okay.
Because if the margin is large, I'm convinced that okay, now I got a powerful signal. Like, but if the margin is small, then I'm still confused. Should I move on? Should I switch to B? I'm confused.
So it is confused. So what will it do?
So if the margin is small, it will take time.
Oh, so it will take more time for switching.
Yeah. Not favorable. More time it will take. Because it will not decide now instantly. It will wait. More time it will take. And if it will take more time, what it will do? Because of that, what happened? There will be no handoff. because it is still thinking, should I initiate the handoff? Because of that, what will happen? Call will drop. Call will drop.
Yeah.
Ultimately, we will suffer.
Yeah.
Why call will drop? Because we are moving towards B and still we are receiving the signals of A, which are very weak.
Wow.
And data session interruption. Call will drop and data session interruption. Is it clear?
Clear, crystal clear.
Oh, nice.